still just doing sine and cosine. The things we've looked at when we graph them, I asked you to list the amplitude, period, count by, and then we learned that sometimes you have to do an interval. When do you absolutely have to set up the interval? Yes, if your x has something added or subtracted. If it doesn't, if you're in doubt, go ahead and set up the interval. It doesn't hurt anything to do it if you don't have to. Okay? Would this be a problem where we would have to set up an interval? We wouldn't have to because my x doesn't have anything added or subtracted with it, but we could. So I may do it just to show you. It certainly doesn't hurt anything. The new piece today, you'll notice in my example, I have this minus 2. What do you think that will do to my whole graph? Move it down 2. Just like any other transformation, if you add or subtract on the end, it moves the whole thing up or down. So, let's kind of make our list. I'm going to look at that and say, okay, I know I have to move this graph down 2. But everything else, we will do our amplitude, period, count by, and I'll go ahead and do the interval, but you wouldn't have to on this one. So the amplitude is the number multiplied with your trig function. What would that be here? Period is the normal period, 2 pi, divided by the number multiplied with x, so that would be 2 pi over 2, which is pi. Count by is your period, pi, divided by 4. Always divide by 4 for 4 quadrants. Interval. When we do this, we set the argument in between 0 and 2 pi. So my argument here is this 2x. If you solve for x, you would have to divide by 2. So we get 0 less than or equal to x less than or equal to pi. Again, you wouldn't have to do an interval on this one, but we can. It just tells us that our first period should start at 0 and end at pi. So, for my graph, here is our starting point, the 0, so that will be my first point. And then I told you for the first, you should always have a total of 5 points, your starting point, and then the 4 following that. So we just add our count pi. So that would be pi over 4, plus pi over 4, 2 pi over 4 is pi over 2. 3 pi over 4. The last one is 4 pi over 4, which is pi, which is where my interval should end. I asked for 2 periods, so we could go ahead and put the rest of the points on here. How many more will I need? 4 more points. So 4 pi over 4 plus pi over 4 would be 5 pi over 4. 6 pi over 4, which reduces to 3 pi over 2. 7 pi over 4. And 8 pi over 4, which is 2 pi.
You know that by a total of 2 pi.
Yes. Alright, now what I want to take care of next is this down 2. The easiest way to do it is just to go on your graph. If I go down 2, that's going to put me right here. A lot of times what I do is just kind of draw in a dashed line, and that's going to be essentially my middle point. So I'm going to be going up and down from that dashed line instead of the x-axis this time. So it's essentially just changed your center. My amplitude is 3. So amplitude is going to be measured from this line. So I'll either be going 3 above, which would be a positive 1, or 3 below, which would be at -5. So we're just oscillating around there. Is everybody with me so far? How does the graph of cosine begin? It starts at its high point. We're not flipping it, so our high point, if we're from here, the high point would be 3 above that. Pi over 4 should be our 0 point, but my 0 here is on my dashed line. Then we go 3 below, and come back. Just keep repeating our pattern. Remember, points on your x-axis need to be spaced evenly. When you draw this, it is curved. I don't want to see, a zigzag. It is a nice curve. Questions on that? You're welcome. Let's do another one of these. This example has pretty much everything I'm going to throw at you in one. So it is absolutely as ugly as these can get. No, I'm just showing you that even the ugliest ones aren't that bad. See? It's all in your perspective, Josh. Okay, if it helps, you could rewrite this. It's like a -2 sine 3x minus pi with a +4 on the end, if you prefer to write it. Yes. So what does a negative do to your graph? Flip it. What does the +4 do to my graph? Okay, so I know those right off the bat. Do I have to do the interval this time? Yes, it is not optional. So my amplitude. Remember, amplitude is always positive. So it's the coefficient, so it would just be a +2. Period would be 2 pi divided by 3. Count by is your period divided by 4 for 4 quadrants. You can use your calculator anytime. You just do 2/3 in parentheses and then divide it by 4. Or if you think of this as multiplying by 1/4, so we should get a pi over 6. Interval. How do we set that up? So then we solve for x. So we will add our pi. Pi, pi. Divide by 3. So our interval will be pi over 3 less than or equal to x less than or equal to pi. So this tells me for one period, my graph would start at pi over 3 and end at pi. So first point is pi over 3. We need 5 total points for that first period. You add your count by. So pi over 3 plus pi over 6, or 1/3 plus 1/6. Should be 3 pi over 6, which is pi over 2. Plus pi over 6 would be 4 pi over 6, so 2 pi over 3. Plus pi over 6 is 5 pi over 6. Plus pi over 6 is 6 pi over 6, which is just pi. So everybody understands where I'm getting those points. Then, those are the first 5. I asked for 2 periods, so let's just go ahead and tack on 4 more for the second period. So plus pi over 6 would be 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, so 3 pi over 2, 10 pi over 6, so 5 pi over 3.
Counting by pi over 6 shouldn't very beginning be pi over 6.
Shouldn't what?
Very beginning be pi over 6.
It isn't, because we didn't start our graph at 0. When we did our interval, our first point happened at pi over 3. So if you hadn't moved left or right, then yes, you would have been correct. Okay, what else is going on with this graph? Up 4. So I'm going to go to positive 4. And I'm just going to draw in a line there to remind me that's my center. So I'm just going to move around that line. My amplitude is 2, so we will be going 2 above and 2 below that line. So my high point will actually be at 6, and my low point will be at 2 on this graph. Okay, we're starting at the pi over 3. That is the first point on my graph. We were graphing a sine. Where does sine start? On the line. So at pi over 3, I will be right here at this 4. And then sine normally goes up, but we are flipping. So at my next point, pi over 2, it's going to go down 2. Back to my 0. Up 2. Back to my 0. That's your first period. If I only ask for 1, that's all you have to do. I asked for 2, so we just keep repeating, following the pattern.
Why did you put it on 2?
Because our amplitude was 2, so you'll go 2 above and 2 below this line. Any questions? So this is as bad as it can get. A lot of repetition on this. So we have a lot of time left. I wanted to give you guys plenty of time to graph these. Tomorrow, I would like to do a quiz over sine and cosine before I move on to the other graphs, because I need to know if we have any problems before we really get into secant, cosecant, tangent, cotangent. If you can do the graphs today, you can do your quiz and be just fine, because the quiz, everything just built on itself. So your quiz will have some nice, simple problems, like we did at the very beginning, so you may have just like a 3 sine of x, or a -2 cosine of 3x. You know, we start with those, then we may have some that just change your interval, and then we'll have some that move up and down as well. So everything you're doing today will help you practice for what will be on that quiz, and it really won't even take us the full hour. I'm planning to start the next section afterwards. So I just want to do that to make sure we're on the right track before we move on to the other pieces. I'm gonna stop this one. So you can add this to the page 155 from Thursday. We're going to do 1 through 8. So get some matching questions in there again. 15 through 18, some more matching. And then the 45 through 53 odd are the only ones you are actually graphing yourself. Yeah, I think that should be it. So you've got time to work on that now.